Good morning. I am Dr. G. Sadish Kumar, Assistant Professor EC Department. Today we are going to discuss about antenna and microwave engineering subject. Uh, Subject code is 1906701. Uh, the content of the topic is Introduction to Microwave, Block Diagram of Microwave, Properties of Microwave, Advantage of Microwave, Disadvantage of Microwave, and the application of microwave. Before going to discuss microwave, first thing is what is wave? Now, I will tell you in physics, a wave is disturbance or oscillation that travels through a matter or space accompanied by a transfer of energy. This is called waves. The wave are two kind of waves. One is mechanical wave, another one is electromagnetic wave. In our subject, we are dealing with EM waves. Therefore, I can concentrate in EM waves only. The electromagnetic waves classified as radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation. So here we are mainly concentrate microwaves because our topic is belongs to microwaves. So now what is microwave? Microwave waves are electromagnetic waves. It is a combination of electric field and magnetic field. It is called electromagnetic waves. The microwave frequency range is 300 megahertz to 300 gigahertz. The wavelength range of microwave in air medium 100 centimeter to 1 millimeter. Next, the other name of microwave is nothing but very short wave because microwave is the shortest wavelength region of the radio spectrum and a part of the electromagnetic spectrum. Next, we can discuss bands in microwave frequencies. The frequency range of 3 to 30 MHz we can call as high frequency band. Next, 30 to 300 MHz frequency range is VHF band, very high frequency band. Similarly, 300 to 1000 MHz is ultra high frequency band. Next in gigahertz, 1 to 2 gigahertz we can call it as L band. Similarly, 2 to 4 gigahertz is nothing but S band. 4 to 8 gigahertz is C band, and then 8 to 12 gigahertz is X band. 12 to 18 gigahertz is Q band, and 18 to 27 gigahertz K band. Like 27 to 40 gigahertz is Ka band. 40 to 75 gigahertz name is V band. 75 to 110 gigahertz is W band. Finally, we can call as 110 to 300 gigahertz is called millimeter band. Next, block diagram of microwave frequency and operations. I mean principle of operation. Here, the transmitting station with microwave transmitter is connected with waveguide with help of RF cable, and also the circulator is connected with waveguide. The waveguide has uh, antenna. The antenna is slotted waveguide antenna. It transmitting the signal. These are the transmitter part. Similarly, in the receiver part, the sensor receives the mobile signal and transmitted to the rectangle. The rectangle is nothing but to sense the signal from sensor, and then it transmitted to the destination. Here destination is nothing but our mobile phones. So here the microwave signal is transmitted from transmitter along with message signal using the slotted wave guide antenna at frequency range is 2.45 gigahertz. In receiver section, the sensor search the mobile signal. In addition, it has a rectangle. The rectangle receives the transmitter power and converts the microwave power to DC power. Next, the transmitter antenna of the section consists of two parts. One is magnetron, another one is slotted waveguide antenna. First thing is magnetron. The magnetron is nothing but a vacuum tube oscillator that generates high power electromagnetic signal in the microwave frequency range. Second part is slotted waveguide antenna. It is an omnidirectional antenna. It used to as ideal power transmitter. Next is it has high power handling capacity. In receiving section, it has two part, one is sensor, another one is rectangle, the basic addition to the mobile phone. Here the sensor uh, is nothing but simple circuit which detects whether the user is making a call or not. Simply F2V converter, this would serve our purpose. Operation frequency of mobile operation of GSM system for mobile communication in Pakistan is 900 MHz to 1800 MHz. The F2V converter is using the IC is LM2907. On the reception of the microwave signal, the sensor circuit detects as rectangular circuit to on. The rectangular circuit converts the microwave energy to DC output. The mobile phone begins to charge using the microwave power as long as the user talk over cell phone. Next part is rectangular. A rectifying antenna called as a rectangular receives the transmitted power and converts the microwave power to DC power, that is direct current power. Here, the Schottky diode rectifies the alternate current included in the antenna by the microwave to produce DC power, which powers a load connector across the diode. Next, the Schottky diode are usually used because they have the lowest voltage drop and highest speed, therefore have the lowest power losses due to conduction and switching. Here the diagram for the rectangle. The input is circuit design. The parts are present here: antenna, dipole, collecting bus. Last one is LOA. Here the F is nothing but low power, low pass filter. Next thing is properties of microwave. The first property is electromagnetic radiation of short wavelength. Then it can be reflected by conducting surface like optical waves. Third thing is microwave current flows through outer layer of the conductor. Then the microwaves are easily attenuated. Therefore, they are not reflected by ionosphere. The advantages and the limitation of microwaves. Here, the micro already I said the microwave band range is from 300 MHz to 10 GHz are capable of freely propagating through atmosphere. This helps in astronomically research of space in the study of microwave radiation from the sun and stars. The next advantages of microwave communication is high bandwidth, higher speed. Because of high frequency, more data can be sent. Second, similar antennas produce a more focused beam. Because of that, short wavelength microwaves use smaller antennas. The disadvantages of microwave communication: they require no obstacles is present in the transmission path. The cost of implementing the communication infrastructure is high. The last disadvantage is microwaves are susceptible to rain, snow, electromagnetic interference. Uh, Finally, we are lot of microwave applications. Here we discuss one by one. The first one is communication application, second one is radar, third one is industrial and biomedical, fourth one is heating. In communication, we can use terrestrial and satellite purpose. Similarly, in radar, we can use civilian and military. Civilian means commercial, air traffic control, aircraft navigation, ship safety, space vehicles, remote sensing, law enforcement. Similar to military, we can use surveillance, navigations, guidance of weapons, electromagnetic warfare. Nowadays, in industrial and biomedical sector, it can use by process control, drying, curing, treatments of estomas, waste treatments like nuclear, cellulosic, monitoring, imaging, hypothermia. Finally, heating for use industrial and household purpose. Thank you for watching this video. Thank you.